Hello guys, welcome to HotCoder. Today we are going to discuss the LeetCode problem number 219 contains duplicate 2. Let's dive into the question. So the problem statement is given an integer array nums and an integer k, return true if there are two distinct indices I and j in the array such that nums of I and nums of j are equal. That is, the selected two indices values should be equal, and absolute value of I minus j is less than equal to k. That is, the distance between the two indices selected two indices should be less than or equal to k. This is the problem statement, and we'll discuss the approach for this problem. So for first test case, we'll consider the first test case and we'll extend the first test case further. So let's say 4, 1, 2, then 3. So let's say it's 4. Okay, so we'll give the indices for each of the cells. So 4, 5, and 6. So we'll consider the elements of window k of for each time. So firstly we'll consider the window of size k. So we'll consider a window of size k plus 1. Why we are going for k plus 1? They have clearly mentioned that the distance between the both index should be 3. So when you see 0, start from 0, we can see that the distance from 0 to 1 is 1. First index is 1, then second is 2, and third is 3. So from the 0th index, we can consider the cases up to 3. So consider the numbers up to 3, and if any of the element is duplicate in the current window, we can return true. This is the condition for our solution. So let's walk through the question. So firstly, we'll consider the first window of size k. So the elements of the current window are 1, 2, 3, and 4. Every elements are distinct. So we'll move on to next index, that is 1. So from 1 we can reach maximum up to 4th index. So we'll consider this window and check if any two elements are equal or not. So from 2 to 1 there are no elements. There are only 1, 2, 3, and 4. Every element in the current window are distinct. So we'll move our pointer to next value. So we'll ignore the before element, that is the index 1, and we'll consider from current index to k plus 1. So the current window will be having elements 3, 4, 1, and 2. So there are no any duplicated elements in the current window. So we'll move on to 3. So we'll start from third index up to sixth index. So the current index consists of elements 4, 1, 2, and 4. So you can clearly see that 4 is present 2 times. So we can return true. Why we are returning true? Because for the current window of size k plus 1, that is there is a duplicated element present, that is 4. So we will return true. So let's do other test cases. So for second test case, the elements are 0, 1, 1, and 1. So for this test case, k is 1. So we'll consider the case of k as k plus 1. So 1 plus 1, it will be 2. So for each window size of 2, we'll be checking whether same element is present or not. If present, we'll be returning 2. So consider the indexes 1, 2, and 3. So firstly, we'll consider the window of size 2 starting from 0. So the numbers in present in current index are 1 and 0. So there are no duplicated elements in the current window. We'll move on, start with the next index. So from 1 to 2. So we can, the elements present in the current window are 0 and 1. So there is no duplicated element. So we'll move on to next index, that is 2. From 2 we'll be checking whether the elements, duplicated elements, are present in the current window or not. So for current window, 1 is repeated, so we'll be returning true. We have met the condition, so we'll be returning true. So that's about the second test case. We'll move on to third test case. The elements are 1, 2, 3, 1, 2 and 3. So we'll consider the window of size k plus 1, that will be 2, 2 plus 1 is 3. So from each index we'll be considering window of size 3. So 3 and 4. So firstly we'll start from we'll start the current window from 0 to 3. So we can clearly see that there is same element present. So sorry, so we need to consider 3 elements. Wait a second. So the window of size 3. So we'll consider the 3 elements, and the elements are 1, 2 and 3. So there is no duplicated elements, so we'll move on to next index. So current index elements are 2, 3 and 1. So there is no any duplicate elements present in the current window. Then we move on, we'll start with 2. When we start with 2, we can reach up to fourth index. So the current window does not have any duplicated value. That is from 3, 1, 2, there is no duplicates. Every elements are distinct. So we'll move on to starting with third index. When we start with third index, you can clearly see that there is no any duplicated elements. That is, this index will not be having um, any duplicated numbers. So we can stop the iteration over here till here, and we'll return false. So the required duplicate condition is not met in the current test case, so we'll be returning false. So I think you will be getting a clear idea of how to do it. Even if you didn't get it, you will find it in our coding section. So let's move on to coding. So before moving on to coding, so what data structure can we use to store the elements in the current index? We can use set. Set will be having a property of storing only the distinct elements. So we'll be using a set. So first we'll be creating a set which will be containing integer. Let's call it as set. So we'll iterate through each index. And firstly, we'll check if the set contains the current number or not. If set contains current number or not. If it contains, we'll be returning true. Next, we'll check if the size of set is equal to k. If so, we'll remove the element which is out of bounds of the current window. So we'll be removing it. So we'll be removing it, and finally we'll add the current element into the set. So it's nums of 5. And finally we'll return false since there is no condition we have met for contains duplicate. So before that, there's a corner case that if k is 0 or k is 1, the window size is 0. Window size 0 will be returning false. So for each window there will be only one element. So we won't be able to have any duplicates because there is only one element present when the window size is 1. So we'll be returning false. So let's check with the sample test cases. It's working fine. Let's submit it up. So the time complexity for this approach is of n since we iterate over the computer array, and space complexity is of k. So the maximum size of the set is going to be k plus 1. So we'll round it off to k. So approach for this question is sliding window and hatching. So thanks for viewing my video. Have a great time.